So I have two slides I'm going to show you. This picture is an iconic photo. It was taken in the last Apollo mission to the moon in 1972 by Harrison Smith and Ron Evans. Ironically, Harrison was the only geologist, the only scientist who ever went to the moon among all the Apollo astronauts and on the last mission. And this was taken looking back a few hours after translunar injection. And it's come to be known as the blue marble, because if you look at it in context with other imagery that we have, it really drives home the striking notion that the Earth is a fragile ecosystem hanging in space in a hostile environment. And what you can see writ large are the effects of climate and weather. And as Betsy mentioned, one of the big differences between climate and weather is, well, it's what you see every day. Climate is what you expect to get over a long period of time. And if you look back at the history of the geological record, you could see large changes in the Earth's climate. The Great Lakes are themselves a consequence of climate change. The glaciation that took place in the last ice age is why we have the Great Lakes. In fact, the Great Lakes and more generally climate change are responsible for many of the things in terms of the ecosystem interactions that have made Iowa fertile farmland, because there are a whole rich set of things over time that have led to those climactic changes in environmental situations. There are other things that have happened as well. We know that we live in a world of punctuated equilibrium. If one thinks about, for example, the speciation extinctions that have taken place as well in the fossil record from meteor impacts and other effects of climate change, it is a fragile ecosystem. Small changes have dramatic impacts. And in fact, if we think about what we've worried about, many of us in our lifetimes, the effect of so-called nuclear winter, should there have been a massive nuclear strike someplace on the planet, those are direct and manifest effects of climate change, at least the potentiality, and something we hope never happens. But that interplay of natural forces and, as Betsy said, of human interaction has really profound implications for our future. And there's a great temptation to believe that the climate just is, and that we're passive participants in it. But in fact, we are active participants in shaping its future. And so I want to leave you with just a few things to think about as introduction to this. And I want to read you just a couple of sentences from the recent Intergovernmental Panel on Climate Change report, which came out just a few weeks ago. Think about these facts. Each of the last 3 decades has been successively warmer at the Earth's surface than any preceding decade since 1850. Now, after last winter here, you may find that hard to believe, but it's the difference between climate and weather. Ocean warming dominates the increase in energy stored in the climate system. Right? If you think about the amount of energy that hot water holds, the ocean is a huge reservoir of energy. Changes in the average temperature of the ocean have profound effects for the global climate. And the rate of sea level rise since the mid-19th century has been larger than the mean rate during the previous 2,000 years. Atmospheric concentrations of carbon dioxide, methane, and nitrous oxide have increased to levels unprecedented in at least the last 800,000 years. Those are big changes, and they've happened post-industrial revolution. And so the conclusions of the latest report from the IPCC say it's extremely likely that human influence has been the dominant cause of observed warming since the mid-20th century. And continued emissions of greenhouse gases will cause further warming and changes in all components of the climate ecosystem. And finally, limiting climate change will require substantial and sustained reductions of greenhouse gas emissions. In other words, if we don't do something radical and we don't do it soon, there will be potentially irreversible consequences. And those of you with mathematical backgrounds, if you know anything about the whole notion of lag and hysteresis, part of what that means is that changes that have already happened are not fully manifest. And it means that changes today will take longer in the future to be manifest. And so even though it may appear that we're not at a point of irreversible change, and we're not yet, but we're really close, if we wait much longer, we will be. And so there are profound motivations for us to act quickly and to act with alacrity. Now, I know in some circles climate change is pushed back as just a theory. But the truth is, essentially every reputable scientist who works in any area related to climate change on this planet believes it's the truth. Now, it's possible they're wrong, but I doubt it. And so what we do has a big implication for us and for our children and for our grandchildren. It's not something that may happen in thousands of years. It's something that's happening now. And so this morning's discussion is really about the technical issues that underpin how we understand climate change and how we can do things about it. Everything from understanding the energy budget of the planet to the effects of particulate matter in the upper atmosphere, the effects of greenhouse gases in the upper atmosphere, and the interplay of human activities on the ecosystem. And so think about the blue marble and what it means for that future. Because as Carl Sagan used to say, this is spaceship Earth. It's the ecosystem on which we live, and it's the future on which we depend. And so I look forward to a really exciting discussion today. We've got a great set of people, and it's going to be a fun discussion about an issue that's crucial to all of us. So welcome. I'm really delighted that you're all here.